Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is C++ pointers. Before proceeding, make sure that you have already watched these other videos first. Some C++ variables, like this ivar, have int as their data type. Other variables, like this pivar, have pointer to int as their data type. When you assign a value to an int, you are giving it a number that represents some kind of quantity. But when you assign a value to a pointer-typed variable, you are storing a memory address. All computer memory is arranged in one long line, and the location of each piece of memory is numbered, from 0 up to however many words of memory that your computer has, which is a very big number. By storing a memory address in a pointer variable, the variable is essentially pointing at that memory location. When your software is being run, it gets loaded into memory at some arbitrary location. The next time you run it, it will probably get loaded into a different spot. Consequently, a location like memory address 20839 with that particular numeric address doesn't have any meaning, not at the time you are writing your code. What is meaningful is to have the ability to point at some data that is important to our program. For example, we might want to have our pivar pointer variable pointing at the location of our ivar variable. To do this, we need to be able to ask C++, at this particular runtime, what is the memory address of our ivar variable? C++'s answer to that question will be different every time we run our software. To ask that question in our source code, we use the address of operator, which is written as &ivar. The result from that address of operation is a numeric memory address, which we can take and assign to a pointer variable. The opposite of the address of operator is the dereference operator, which is written *pivar. Dereferencing takes a pointer variable, follows that pointer, and then indirectly uses the integer at that location that had been pointed at. Because this was a pointer to int variable as opposed to a pointer to something else, this dereferencing expects that pointed at value to be an int. You can also indirectly modify this integer by putting it on the left-hand side of an assignment. Note that this causes a side effect of affecting ivar's value. If two variables have the same base type, they could be defined on the same code line. We usually don't do this, however. This example illustrates why it's a good idea to avoid that ability. You might wonder, is ivar's type an int or a pointer to an int? The answer is that it is only an int. Modifiers, like that star symbol, only affect one variable. By the way, the reference modifier also only affects one variable. For pointers, there are two forms of constancy. You can use neither form, either one form, or both forms. Writing the const keyword to the right of the star symbol denotes a constant pointer variable. The pointer variable is not allowed to be changed to point at something else. However, the pointed at element itself can still change. Writing the const keyword to the left of the star symbol, either before or after the type, denotes constant elements. The pointer variable itself may still be changed to point at a different constant element. When a function's parameter type is const_char pointer, the function is guaranteeing that it will not modify any of that string's characters. If the function might modify some characters, then the type is merely char pointer. But some lazy function programmers define their parameter as merely char pointer even though they aren't modifying any characters. If you know for certain that is the situation, then you could still pass a constant character string by casting away the constness of your string.